Okay, so far all of our TDD has been concentrated on the controller, and we've sort of been putting off this idea that, well, the real work gets done in the model. We haven't actually dealt with that yet. Right? We've just faked it out everywhere that we needed it. So now let's do that. And kind of as a preview to doing that, and you already saw sort of a taste of this in the Oracle of Bacon homework, is even if the real work is occurring in the model, part of the real work is talking to an external service. And as we know, in test suites, it's not really appropriate to do that. So this one example that the book develops to show how we're going to handle TDD for the model method is this idea of explicit versus implicit requirements. So we already know that we already laid out the explicit requirement for what this hypothetical model method is supposed to do. It's going to call this Ruby gem, which in turn calls the TMDB service. And by the way, if we didn't have a Ruby gem, what would we be doing? Well, we'd be doing something a lot like what the Oracle of Bacon homework was doing, right? We would have to construct the correct type of URI and get the response and parse it and create a nice Ruby object. It's just in this particular example, the TMDB Ruby gem does a lot of this for us. So that's the explicit requirement. But the implicit requirements come from things like, well, what if that doesn't work? What are the reasons that that might go wrong? And two specific cases are if you provide an API key that's not valid for calling TMDB, or if you just don't provide the API key at all, if you leave it blank. And as the book describes, if you go through this example, those are actually two different failure modes. And you can imagine why, right? If the key is blank, clearly that's wrong, because no legal key is ever blank. But if the key is not blank, then you have no way of telling if it's valid unless you actually try to use it. So the gem will actually fail in two different ways for those two different conditions. And this is a good motivation for how to group tests using context and describe. So here's an example of blocking up the tests. And by the way, I should point out that describe and context are fundamentally aliases for one another. They actually call the same underlying method. So why are there different words? Because it helps you signal intent, right? Describe is saying, here I'm describing a behavior generally, searching TMDB by keyword. But context lets you say, these are different situations under which this behavior might be triggered. One context is if I do it with a valid key. A different context is if I do it with an invalid key. And by the way, within invalid keys, there's at least two cases. There's the key not being given at all, so it's blank. And there's the key being given but incorrect. So basically, I'm grouping together chunks of tests. And what are the groupings are sort of based on whether it's a collection of examples that are testing related behaviors. And also, as the book explains, if you have common preconditions that apply to all of the tests in a group, like they're all going to use the same stub, or there's a mock that all of them are going to use, you can put a before block that applies to a whole bunch of tests so that you don't have to repetitively repeat those preconditions in every single example. So where are we? The implicit requirements are derived from the explicit ones. And in the example of TMDB, how do I know that the gem fails in two different ways? Well, for one thing, I read the documentation. It's a new concept. Most of these are well documented. In fact, part of the documentation for good Ruby gems is their specs. And by the way, if you're using a gem and you can't find the specs that go with it on the download site, that's a sign that it's either poorly tested or it's so out of date that the specs haven't been maintained. You don't want that, right? You want libraries that are actively curated and actively developed. And having a good set of specs is actually a really good ecosystem indicator of if the gem is trustworthy. And you can also, as you design your classes and you're experimenting with these pieces of code, you can actually see how they work, and then you capture that behavior in a test. We'll have a lot more to say about them when we talk about legacy code. So we use two different stubbing approaches in this case. In one case, we know that TMDB gem will immediately throw an error. So the only test we had to create there was, did we catch the error and convert it to the right kind of exception, so that the caller always sees an exception of the same class. And in the second case, we actually needed to prevent the gem from contacting TMDB at all. Now, this is the case where, in the way the example is developed in the book, and very similar, again, to the Oracle of Bacon homework, we used fake web to sort of stub out the entire internet. The general question that this leads to is, when you're testing pieces of software that work in a service-oriented architecture, where should you stub? And remember that you can sort of apply this either from the point of view of, I'm writing tests that are going to reach out, they're testing code that reaches out to an external service. So in that scenario, I am the client, and I want to write tests that are going to talk to another server, but I need to be able to stub out that server to keep the test fast and independent. And another case, as we'll see when we talk about JavaScript development, JavaScript runs in the client, and you often want to be able to test it in isolation of the server code that it depends on. So the concepts here actually come up in many different scenarios. So where do you stub? Well, we've already seen that you can do things like stubbing methods directly in our model classes. I think the analogy that one of the students just gave about a stub as a way of cutting off of a path, that's exactly how we're going to think of it here. We're cutting off a path, right? If we say stub the movie, or stub the find in TMDB method right in the movie class, in some sense, we're cutting off the path at the earliest possible opportunity, right? We're not even allowing the real method to receive the call. We're just going to, everything below this line is faked out. We're going to pretend all of this stuff worked, and we're going to return a canned value. We could also stub below the level of the gem. So this says, look, we're going to call our movie method, we're going to call the real thing, but we know that our movie method is going to actually call something that's in this gem, in this library, so that's where we're going to stub. We're going to stub the gem instead. So this says, I'm happy to actually test my part of the code, but I want to stub out the library. Going further than that, we could say, ultimately, if the TMDB gem is going to call an external service, it ultimately has to go through one of Ruby's class libraries that allow you to do HTTP calls. So we could just stub that. We could stub the HTTP call and make sure that the correct URI is passed, and we could return the contents of the page. And this is the kind of thing that fake web sort of does for you. And then if we're going to do that, well, what we really do is we can parse a contrived request. We can look at the real service. We can do a couple of requests against it. We can capture exactly what the output of those real requests was, and then we can use those canned values for something like fake web. This is what the Oracle of Bacon homework does, and this is kind of the standard practice when you're trying to code against a remote service. You learn as much as you can about its API, about what it returns. You ideally do some interactive tests on your own using a command line tool like curl to actually see what happens when you stimulate it, and then you capture those results and you sort of freeze dry them, and you use a gem like fake web. Another possibility, which we haven't done, but it's something that you might do if you were the provider of the service in the service-oriented architecture, is you could put up a development version. So for example, if you write an app that runs against PayPal or against Stripe, which are services for accepting people's money, right? Pretty important function. Both of those services have a developer sandbox that behaves identically from an API point of view to the real production site, but happily it doesn't cause any actual money to change hands. So the idea is that you would do these other levels of stubbing in your own application, and when you're ready to really test it, there's one more level of qualification you can do, which is test your full stack against their sandbox server, which doesn't necessarily do real requests. So not every service that's out there has a sandbox version of itself. In the case of the Oracle of Bacon, it's hardly critical. But in the case of things like payment services or authentication services, if you're writing a Facebook app, Facebook has some test services that you can use to test your app against. So the idea of stubbing at different levels is pretty pervasive. And the rule of thumb is that if you're doing more unit testing where you're trying to cover a lot of special code paths in a small amount of code, it's fine to stub nearby because what you're aiming for is isolation, right? You want to isolate the code being tested from the side effects of all the other pieces. But as you move kind of higher in the testing stack towards integration testing, with integration testing, you're supposed to be removing more and more training wheels, right? So in those cases, you stub as far away from as you can because the goal of the integration test is to be close to reality. And sort of what's the closest to reality you can get without contacting a service? Well, it's to get sort of all the way down here where you're essentially stubbing out the internet, and anything that goes wrong would be something as in the actual network interaction. So we can, once again, enhance the things that we know how to do in tests. We can, the book example develops this in more detail, and I didn't have time to cover the example in detail in lecture, but just like with stubs and should receive, you can specify that a method should return something. You can also specify that under certain circumstances it should raise an exception. And if you put an action or a lambda expression inside braces, it will allow you to test that it raises an error. This is pretty important because, as you probably figured out during the course of homeworks for this class, if you have a test case that actually raises an exception, the test is over, right? Raising an exception is an instant failure. So how do you actually test that something correctly raises an exception when that's the behavior you're interested in? You can basically put the test case itself in braces, which is just like a block. And that means that you're creating a lambda expression that can execute basically in a controlled environment, right? RSpec will execute it, and it will rescue the exceptions and make sure that the right ones got raised. So with that, we're ready to ask a question about implicit versus explicit requirements. So which statements are true regarding implicit requirements? That they're often but not always derived from the explicit ones, that they apply to unit and functional tests, but they do not apply to integration tests, they're lower priority for testing because they didn't come from the customer, or all of the above are true.